channel Space Remote Sensing and GIS. Today we will going to discuss a very important topic that is called burn severity. Okay, to generate a burn severity map and ecological risk assessment, if you want to do, then how we will going to do that. So this same kind of demonstrations I already explained you in ArcGIS Pro. Okay, if you go my previous video, you may found that forest fire burn analysis. Okay, but now this in this particular chapter I will going to focus over the ENVI. Okay, so in ENVI how we will going to do this burn severity index, okay, using the ecological risk assessment. So that's you can do in the ENVI software. I will going to explain you that particular. So before that I will just going to show you. So if you want to understand the forest fire assessment using the analysis change direction tool inside ArcGIS Pro, so I will suggest you should go with this particular lecture. So then you will get all the informations how we will going to do this in ArcGIS Pro. But here in ENVI, as you see here, I have the two images of Ali. Ali is a special sensor which is also having the same path of Hyperon satellites. Okay, so it having almost, you just see here, 1 to 7 bands will be there. Okay, so one is pre-fire incident and one is post-fire incident. If you see here, this is the two images we have. One is pre-fire, one is post-fire. Okay, so how I'm going to understand the burn severity index, which are the area which is mostly burned, that I want to create a map. So then what is the process I will going to show you in this particular lecture. So in my previous lecture we are already discussed about the various things, just like as you see here, I discuss about the avalanche. Okay, I discuss about the flood analysis. So now why not we can try to do over the burn severity analysis also. Okay, so let's start the lecture. So to very first thing is, when we are starting this is my radiance image. As you see here, this is a early radiance image. What we are going to do it here first is atmosphere corrections over the image. So to doing the atmosphere corrections, and we have a very good options over here. Okay, so if you see here, we have the radiometric correction tool. Okay, so under that we have atmosphere correction model. Okay, so atmosphere correction model if you have, then is well and good. If you don't have this module, then you can go with radiometric corrections process. Okay, then also you can calculate the reflectance. So main objective is you have to calculate the you have to do the top of atmosphere correction process. So quick atmosphere correction is a very good options for that. Okay, so directly it can calculate your those things. So I will first thing is I will going to apply it over the pre fire incident. Okay, data set. So I will select it, simply click on OK, and here you can give a name of that is pre-fire. Now I just copy it and I will just save it like this. So pre-fire only thing is which I will going to apply, that is quick atmosphere correction process. So I will just going to type QUSC, so which will going to demarcate it as a quick atmosphere corrections over my image. Okay, so this is a pre-fire dates. So simply click on OK. So I already have that same area, I already have that. So I will just give one different name. Yeah, so now you see it is start processing. So let's see the result. Yeah, so once it is done, so now you see the pre-fire datasets will now ready. Okay, so now the same process we need to apply it over the post-fire datasets also. So we'll switch off this pre-fire datasets. Now post-fire data, I'm going to apply the same technique. So to applying the same technique, you just need to click over this quick atmosphere corrections. Now select the post-fire datasets. Okay, so click on the post-fire and you have to give the same name. Okay, so this is the post-fire. Okay, so I will just paste it there. So I can give the same name as a 2. Okay, so simply click on OK. So this is my post-fire UUAC image. So this is a quick atmosphere corrected image. So let's run it and let's wait. Now it is done. Okay, so you see it is done. So I have my post-fire and pre-fire after atmospheric corrected image. So as I don't want this two image, so I can remove it from here. See, if I remove it from here, it will not able remove from your data manager. So better is you can remove from your data manager, so that the condenser means it is very much congested if you are opening all those bands, okay, which is not required. So just remove this pre-fire, you just simply click remove, and the post-fire also simply select and remove. So now I have the post-fire and pre-fire, two images I have with me. Okay, so the next thing what we'll do, next thing which we're going to do is, that is, we have to subset this, sorry, we required one digital elevation data, okay, to calculate the slopes, because I have to create a mask over a certain slopes where there is a less chances of burning and where there is a most chances of burning. So that area I have to create a new mask. Okay, so for that I have already have one dem which I will just try to open it here. So suppose this is my dem, so it is, you need not to open the dem directly, but if you want, you can directly calculate the slope from the dem. So how we going to calculate the slope from the dem? So for that you need to go to this terrain tool. Another terrain tool, you have options for topographic modeling. Okay, so you just see here. So now here input data, you need to select the dem, okay, and you need to calculate the slope. So I'm just selecting the slope and then simply, so before going to save this, you can give a proper name to save this layer. So suppose in this I'm giving a name something like this. Slope. Okay, so this is the name I just given for this my layer, output layer. Okay, so I can give this as a 2 again. So simply click on OK. So if you do that, it will calculate the slopes. So if you don't require the dem, so you can remove the dem from here also. So from the data manager we can remove later also. So now the next important things which you have to do it over the image, that is now you just see here we have pre-flood and post-fire. This is the where the forest fire is actually happened. So that I already created one RY, and using the RY I will concentrate only this particular area, and I want to extract this particular forest fire areas. Okay, so for doing this I will just click over this tool. Okay, so I have this fire extend XML tool, so that I just open over my formalized. So also you can do this. Okay, so simply click on OK. So if you just click over, then see, you can able to see this. Now using this AY tool, if you want to cut, so that also you can do. But yes, the 5.7 they are actually changed, they remove this particular tool actually. Okay, so if you go in a region of interest, there is no tool of RY, okay, subset by RY, so that is not there. So you can use the another process to doing the subset. So that is very easy. First you need to select this particular formula soaps and come to the file. Okay, and here you come to this as a save as. So once you come to this as a save as, so if you want to cut and subset this particular area, so select this from the spatial subset. Okay, and here you can use this RY tools. Okay, so select it, click on OK, and similar things you have to do for masking. So select it, click on OK. So if you do that, simply click on OK. So here you can give the data ignore value as a 0. Okay, and then simply give the output file name and save this. So I can give this name as like this, so that I can identify. So subset. Okay, so this is the name I'm given it here. So simply click on OK. So now once you do it, that see, if you give this not 0 value, so it will cut exactly with the shape. So you just see here, it is cut exactly with the shape. Now the same thing we need to do it over this image also. Okay, like post fire and the pre fire. So the same process you need to follow and extract the same area. So first we go to the post fire. Suppose I will go to the file, then save as new here. Okay, so select this. Okay, come to the spatial subset. Okay, select this RY tool. Okay, so now once you do this tool, so simply click here. Okay, and you can give the file name. Okay, so this is the name which I provided. Okay, and then simply click on OK. So now you see here, now this area is also cut it out. Okay, so if you see here, so you can understand this. Now one thing is left, that is the pre-fire data. So that is also you have to cut the same process. So select it, go to the file. Okay, so now save as new. Okay, spatial subset. Okay, so you can select your RY tools, select the RYs. In the mask also you can select the RYs. Okay, and then simply click on OK and give the name. Okay, so this is I given the tutorial 2008-9. It is a pre-fire image, and quick atmosphere correction is also done over it, and then subset. Okay, so I just click on OK and see here it is also cutting out. So now whatever I not required, I can remove it from here. So it's not required. Okay, so I will just remove to formula and slow. Yeah, this is also not required, so you can remove it from here. So you can remove this first. Okay, so and then you can remove this also. Okay, so these are all the extents which is required. So now you can pull to extend. You can see here this is a post fire. Okay, this is a pre-fire, this is a post fire, and this is your slope image which is required to create the mask. Okay, so the mask area I will going to create now. So now here also from the data manager, whatever you don't require, you just remove it from here also one by one, so that it will be easy for you to understand whatever layer is required for your analysis. Okay, so I will just go in these three things. So I don't want this also, I don't want this extent also. So, okay, so this is the three layer which is very important for me now. Now the first thing I will do it here, that is I am going to create a mask over this particular slope. So to creating the mask layer, you can go to the raster management tool. Here you have the build raster mask options. Okay, so you can use this tool. Okay, so build raster mask. Okay, so this I want to create. So over which layer I want to do this? I want to do this over my slope layer. So I will select the slope layer and simply click on OK. So now here I have to give a certain range. Suppose this range which I feel that is the slope area which is from 25 to 60 degree is suitable for the burning. So that area I will give you as a value 1, and whatever the value area which is not coming under this, I want to give as a 0. So that's what I want to multiply. I want to do over 0 and 1. I want to multiply like this, and that will going to reflect over my image. That is what masking we are doing. So for this you can go with the import a data range. So I will select this formula in slope and simply select it OK. So here you need to write down your slopes. So minimum value I given as a 25, and the maximum value I have given here as a 60. Okay, so you just see if I click on OK, so this range will come. Now I am giving the name of this layer also. Okay, so as you've seen here, I just given this mask slope GT over there, and then I can simply click on OK to run this analysis. Okay, so simply click on OK, and you see it will okay. No problem. I will just going to create a new layer. So simply click on OK. So you just see here, this is my mask image is ready, which I will going to apply for my change analysis. Okay, so sorry, for a change detection window, which will workflow which I'm going to apply to extract the most burned area. Okay, so this most burned area, if you want to calculate, so I need to go to this particular workflow tool. So here we have the change workflow detection. Okay, change detection workflow. So that I'm going to use it here for this particular analysis. So if you have the older version, so you can go with the okay, so in the image change workflow also you can go, or if you have this one, so you can go with, suppose you have version 5.7 or above, so then you can go with the change detection workflow. Again I'm telling, if you have the 5.6, you can go with the image change workflow. So that will be most better way to do this analysis. Okay, so now suppose the input raster and output raster, I need to give the my input. So the pre-fire incident data I am just going to select over raster file 1. So this is a pre-fire, and over this you want to apply the mask. So click over the mask and select the to mask GT which you are created over it. So simply click on OK and simply click on OK. Now it's a mask tool. This is for the pre-fire. Okay, now the same thing you have to do for the post-fire. Okay, so select it, click your mask. Okay, so select this as a mask as an input, and then simply click on OK. So now you just see here my two mask image is ready. So now if I go to the next, okay, so here it is asking for this registration process. So you can skip this registration process also. Okay, so I will just going to skip these steps. So now here it is very important step here. So here we have the band difference options will be there. So we just focus over the vegetation indices. Okay, so because on the basis of vegetation indices we are going to identify. So in the vegetation indices lot of options will be there here. Okay, so but here our focus is over the burned area. Okay, so that's why we are going to select the burned area analysis. Okay, so you just see here burned area analysis. So that's what I'm just going to select it over here. Okay, now this is ready, this area, this one is ready. Now you can go with the next. Okay, so you just see here that's over the most burned area and mixed burned area. So that is now coming the value range. It's very coming low because it's a that range which is coming. Okay, so that is low value, so that's why it's coming like this. But anyway, so we got this, and now next if I go, okay, so now it is asking me to create the outputs. Okay, so minimum kernel size or maximum kernel size you can give it here accordingly. Okay, but that output it is already shown to you. So if you go to the next, so this is the last steps which it will going to create. Okay, so it is a thresholding raster it is creating. So now here you need to give whatever the output you want. Okay, so you want a classify raster, so you can give the classify given name. So if you don't want to export shapefile, just switch off the shape files. Okay, so if you want to export the difference image, yes, I want to export it. So I will just give a name diff class. Okay, so this is a diff class and this is the classifier. So two image I am going to produce from this. So let click the finish and the rest let wait for the results. Okay, so you just see here now the two images which is created. Okay, so this is the difference image. Okay, so and this is so this is your maximum burned area. Sorry, if I open it, so this is the area, okay, which is found as a maximum burn on these particular locations. Okay, so that is the way how we'll identifying those locations which is the most burned area. So this is the most burned area which we focused over the analysis. So as you've seen here, this is the difference class image. So if you just switch off this, so in the difference class image you can put a color and grayscale, and then also you can get understanding. Okay, and if you want just using the color you want to understand where is the high value or where is the low value, that also you can use like this, the rainbow color you can apply it. Okay, so you can see those are the most burned area which is actually your these areas which I highlighted. Okay, so these are green areas which is here highlighted. Okay, so that is perfectly match with the map. Okay, so that is the what the differences image we are actually creating. Okay, so if you want you can do the slicing also. Like here there is one tool is called new slicing. Okay, we know about all the slicing, density slicing techniques. So if you want to apply the density slicing, you can applying the certain range also. Okay, so you see there is a certain to certain range there is a value. So this is a value is very minimal changes, but still you will get in your classes, and you want to merge those classes and you want to put it on this, so that you can do here also, like band slicing changing techniques. Okay, so if I want to go to the edit raster, and according to edit raster I can select it. Okay, so that is the process actually how we are actually going to do this particular analysis. Okay, so see here is the value how it is ranging is coming and how it is affecting over your burned area. So this is the total map of you can say the what is called burnability index. Okay, so that is burned area vulnerability index. So what is the high burned area, what is the low burned area, very easily we can demarcate it, even we classify it also, and it is very nicely shown over my classified image. So this is directly those areas which are highly burned. So that's all from my side for today's lecture. So if you found this lecture it will be interesting, so please share this video with others, and please give comments. Okay, so next week we will come with another exciting video. Thank you very much all.